Hello, everyone. My name is Ashwin Patil. Thank you for joining me for my talk titled Builtin with Kusto Query Language. I also wanted to thank GrayHat and Builtin Village for organizing this and giving me this opportunity to talk. So let's get started. So as you can see my title slide, this is the glimpse of the KQL query that we are going to talk for next 40-45 minutes. Even if you are not seeing the KQL language, this is how it looks like, and then we'll get introduced to you slowly in this talk. So as you can see, the GrayHat 2020 is the table name. Pipe symbol is basically forwarding all your output of the first command to the next. The talk title is the blue teaming. I also projected certain fields in the output called speaker name, company name, Twitter handle, and content link. All of the slides and the KQL queries that I'm going to talk today will be available on my GitHub. So feel free to reach out. So about me, I currently work as a senior program manager for Microsoft Threat Intelligence Center R&D team. My team is also called as Mystic. My team primarily works on a variety of Microsoft threat protection products, such as Azure Sentinel, Microsoft 365 Defender, Azure Defender, and etc. For those of you who don't know Azure Sentinel, it's basically Microsoft's SIEM solution that was released last year. And I'm also primarily working on the Azure Sentinel. So I've been in the security industry for around 10 years now, primarily worked into security monitoring and DFIR space. For the KQL language, I've been using it for around 3 years. So even though Azure Sentinel was released last year, the KQL has been around for more time, available in other products. I also write blogs on Azure Tech Community on topics threat hunting and Jupyter notebooks. You can find my blog and variety of people writing on Azure Sentinel and KQL related things on this particular link, which is aka.ms/Azure Sentinel blog. So today we have a very packed agenda. We'll start with the primary question, like why you should learn query language as a defender. Then we'll introduce you to the KQL language. We'll slowly move this talk from basics towards the end-to-end use cases at the end, right? So we'll first start looking at what is the basic structure of KQL query looks like. What are the most commonly used search operators? How do we explore various tables, schemas, those things. From an incident investigation point of view, we'll look into a certain section such as how do we query asset or device details from variety of data sources. From the KQL features, we'll look into query parameterization. Dynamic data types is one of the powerful features that we'll look into in this talk. Couple of features that we'll look into is like date time operators. How do we extract via regex? Function is something that you will often use when you want to replace the repetitive code with template functions. External data is another important operator to access the data which is currently not present in your SIEM. Then we'll look into a couple of threat hunting use cases. The first one will be the time series anomalies. The second one is the network beaconing. Lastly, I wanted to include a notebook, Jupyter notebook demo, and then show like what are the KQL programmatic interfaces available through the open source library MysticPy that my team has worked on. And we'll conclude the talk with the playground trainings and resources related to the KQL. So why we should learn query language? Now, query language is not the new thing. If you are familiar with the other products such as Splunk, Elasticsearch, they do have their own query language. So why you should learn the query language, right? Most of the times you will be fine by using the most commonly used search operators. But these are some of the reasons for which you should learn query language. So the first one being is the data cleaning and pre-processing is often required prior to analysis, right? So even if you are done very good normalizations at ingestion and have pretty good balance schema in your sim, there are often steps that analyst has to take when he or she is doing the threat hunting or investigation. So that can involve multiple steps such as cleaning the empty columns or deriving new columns, filtering the values, summarizing, and a bunch of other things. So for those operations, for those basic and some of the advanced operations, it's good to have knowledge of the query language. The second is the time is an critical factor when you're doing or working on the investigations. So anytime you can get faster and efficient data analysis in less amount of time can really makes a difference. So many times if you know ins and outs of the query language, that will really help you while doing the incident investigation. The third thing is nowadays, like whenever you start with the broad threat hunting hypothesis, often you will your results will be in thousands or even in millions at times, right? From getting finding the actionable insights from those large number of events is not an easy task. So you need to know variety of approaches through which you can slice and dice the data, right? The last thing is if you know the query language or if you master the variety of angles of the query language, you'll be able to leverage the full power of your SIEM products, right? So most of the modern SIEM solution have advanced features such as statistical machine learning embedded into as part of the query language. So you will have to, if you wanted to leverage those capabilities, you will have to know query language and variety of its features. So let's start with the what is the KQL query language. So KQL stands for Kusto Query Language. There's actually a variety of, the acronym actually matches with variety of languages. Even Microsoft has one keyword query language. There's also Kibana query language. So it's slightly confusing, but if you're talking in terms of log analytics or search products, Kusto Query Language or KQL is the term that you can use. So as you can see on the image, the KQL currently powers for multiple products. The first one is Azure Sentinel with log analytics, which is also called as Azure Monitor. The Azure Data Explorer is the previously known was Kusto ADX, and then Microsoft 365 Defender, or previously it was known as MDATP. It also has advanced hunting query interface, right? So one of the things that I wanted to highlight is even though the language is same across variety of products, there is a varying support between products. So if you look at the KQL docs, you might see this pivot to select your service. So for some operators, as you can see in this example, it's not supported for certain products, right? So this is the link where you can see what are the primary operators. It's a small list, but it's good to know when you explore the KQL docs documentation. Now let's start with the how does the structure of basic KQL query language looks like. So if you are familiar with the SQL query, it pretty much looks like the same, but it has more powerful features than SQL that will look gradually in this talk. But on a high level, these are the variety of sections that you can think of when you're writing the KQL queries. So the first and foremost is variable declaration. So KQL has KQL has operator and functions terminologies. So anything which is in the this pink or magenta color is operator. So let, where, project, limit are operators. And then there are some functions such as ago and then this parenthesis, right? So in this case, we have declared the variable called time frame equal to 1D, which is 1 day. And then the next thing is the table name. So table is the the data source that is onboarded to Azure Sentinel or your variety of other products such as Microsoft 365 Defender. So those products will have the tables available. So you'll be querying for respective tables. And then you will do certain filtering. So first could be date time filtering. This is always a good practice. Even though UI has a default date range picker, it's always good to have good to embed the time-based filtering in your query as a thumb rule. As you can notice here, you can do multiple steps of where, right? So the next step, I'm doing a specific type of event ID, which is like mailbox logging in Office activity logs. And then another field that I'm checking is logon type not equal to owner, right? So you can have like multiple steps of filtering, but it's always good to have date time filtering as your first filter, right? The project is the one where you can through which you can manage the outputs. So these are the various fields that you are outputting. The limit is the good practice to limit your search results to a certain number, so you are not exposing the CPU and memory intensive operations. So let's look at some of the commonly used search operators. So the first one is the search. It's not recommended to use this operator unless you do not know the output tables or the schemas. So sometimes you will ingest some of the custom logs when you may not know the underlying tables and schema. That time you can use with the smaller time window. So in this case, the first query is like we are looking for some bad account in all the tables in last 4 hours, right? So this will basically output all of the data sources which has this particular term, irrespective of which column it is present, right? The second thing is we are looking for IP address as a search term in couple of tables, which are like network data sources. So Azure Network Analytics and then common security logs. The next thing is pretty much straightforward. We are sorting the data by time generated in descending order. The next thing is filter. You may already seen this. Aggregation. You can do summarize count by single field, or you can do a comma separated list of fields here. Let's start looking into the tables and schema. So as I said earlier, the Azure Sentinel or other products has this tables concept. So you will have multiple tables inside of it. So in case you want to query the metadata about tables, there is a table that's present, which is called usage, right? So it has information about all the tables that are present in that workspace or cluster, right? So this query is going to show you all the data sources, which is shown in this field called data type. And then we are summarizing the data size in MB and then querying for last Monday. So the output of this query will show in last 24 hours how many data sources are present in the workspace, and then what's the size of each of them in a descending order. The next thing is the get schema operator. This is a crucial operator through which you can see the data type of each field inside of your table. This is also useful when you want to, let's say, run any function on certain columns. You can actually run this command, get the output of list of columns, and then select certain columns, and then use certain loops, and then apply certain function. This is kind of intermediate level, but these operators really come in handy if you know it prehand. The last thing is the workspace operator. Now in Azure world, you will typically have if you're a larger organization, you may have a multi-tenant workspace with multiple workspace and multiple tenants. So in those cases, your data may not be in a single workspace. So if you want to access single table or multiple table from multiple workspaces, this is how you can access, like union workspace, the workspace name dot the table name, right? In this case, I'm looking for heartbeat tables in both the workspaces. Awesome. So now let's look at the gathering the asset or device details. So this is one of the first operations that you will do while investigating the potential alerts or anomalies. Now, if you're a mature organizations, you may have your own asset inventory program, and then you may be managing your asset in some kind of databases. So in those cases, you can bring that data also into Sentinel as a custom log table and then query to that table. If not, there are certain tables that are present in Azure Sentinel and 365 Defender to which you can query and then get the answer. So in this case, I'm looking for the heartbeat table for this computer IP, this IP, and then gathering the details such as what is the computer name, host name, IP, what is the IP country, which is like this is a public IP, so it will output the country name. Other fields such as computer environment, OS type, OS version, subscription ID, and tenant ID. Right. In order for record to appear in the heartbeat table, you will have to onboard via OMS agent, which is currently supported on Windows and Linux in Azure, or you can also install on-premises host as well. So if you have access, or if your organizations have licenses for Windows Defender, there are certain tables that you can query. The first one is the device info. In this case, we are pretty much querying the same sort of information with different details from a different product, right? So device info is the table name, where device name is the control. So host, I'm looking for anything which does not have OS, and then projecting certain fields in the output. The another table which is important is the device network info. Sometimes you may have to map private IP to public IP. So device network info has the network adapter details. So you will typically get private IP from this particular data set, right? And then these are the certain fields. You can notice there, here we can also get the MAC address. Okay, next thing, query parameterization. So this is another important concept. It will make your query readable, and also you'll make less mistakes when you declare the variable. So you'll have to change values in only at the single place. So in this case, we are looking at the two variables. The time frame is the single 1D, and then this is the dynamic variable, event name list. So there is a function called dynamic, and then you can pass a list of values inside of that. And then you can compare with with the tilde sign. So anytime you will see the operators with the tilde sign, that indicates it's a case insensitive match, right? And then you are enclosing that within a parenthesis. The next query, okay, this is going a little bit bigger now. We are looking for dynamic list. In this case, I'm looking for certain tokens. So these are the terms that I'm primarily looking in my data sets. So this particular detection actually looks for anytime somebody has created a VM inside of Azure with a very high CPU. So this indicates it's an expensive operations. So typically crypto miners tend to run VMs with a large number of CPUs or GPUs. So you can look for these sort of queries. In this case, I have these number of CPUs here, right? And then I'm looking with the has any operator, right? So this is an example like of VM template. So standard underscore M416. So 416 indicates number of CPUs, and then this is the template. Now there is a difference between has and contains. So has looks for a whole term and not the substring, right? So example of substrings is here, like admin, which is part which has prepended with ABC and closed with the 1 to 3. All right, dynamic data types is one of the powerful, and then it will really distinguish from a normal KQL user with the pro KQL user, right? So even if you are not a developer, you may already know that there are data types called array and dictionary. So array is the least of types, least of elements of a common data types. So typically you will perform operations such as create, aggregate, expand, and manipulate. So these are the operators that you will need to know when you are manipulating the array data type. And then similarly for dictionary, many times, many of the data sources, currently cloud-based data sources, have JSON objects, nested JSON objects. So these are the operators that you will need to go through. The next thing is date time. Now, the first thing that I wanted to show here is the converting it to a to-date time function. So sometimes your data type will have dates into a string format. So the first thing that you'll have to do is convert into a datetime format. So once you convert it into datetime format, you can use the datetime specific operator. So these operator expects the value or field into a datetime format. So this is another example where I'm basically using format datetime and then formatting this datetime into this particular format. The regex extraction. So many times your data will be as part of some text blob. For example, the command line may have IP addresses or URL. So if you want to extract those details, you'll have to use regex thing. So in this case, I'm using private IP regex and then looking for matches regex. So anytime this regex matches, populate the value as private. If it does not match, populate the value as public. This particular detection looks for anytime there is a firewall block from a Cisco device, followed by the successful sign-in log on Azure from the same source IP. Now, MV apply is another thing which is basically allow you to loop through your fields and then run function, right? So if you have seen SEP logs from a common firewall vendors, they will generally have a placeholder called additional extensions that has a multiple key value pair. So you can see country equal to this separated by semicolon. So this particular query is a dynamic query. If you have to do this in KQL, you may have to do extend and country equal to use regex to extract this. Instead of that, you can take a dynamic approach since you will pretty much rename the columns. So the column names are already present here. You can do extract column key and value, create a dynamic pair for that, and then convert into a JSON object. So this is how it will look. It will be easier to access these elements shortly. So function is another thing where whenever you have like repeated set of codes that you want to use. So in this case, this is a user-defined function. We are basically looking for get all alerts on host. We are passing the parameter called date time and the host name. So anytime you pass the host name, it will basically look for all the alerts associated minus 3 days from this date time and then plus 6 hours. The next thing is before writing your own function, just check if KQL has a built-in function already for that. So these functions, the built-in functions are always optimized for performance to run at scale. So this is the first example, parse underscore path, right? So this will help you to basically parse the file name and then extract certain details. So anytime if you want to extract a file name, extension, or directory name, these are the operators that you can use. So the parse underscore path will convert into JSON, and then you can access the So this is where it comes down. Like if you don't know these functions, you will try to basically convert this into string, separate by slash, and then separate by dot, and then extract this element, right? So instead of doing that multi-line code, you can just use the parse_path function. The next thing is IPv4 is matched. Now, one of the thing that Defender has to do is basically it has a list of subnets, and then if he has to check within the data set if that IP belongs to this subnet, this is the function that you can use. Now, IPv4 is match expects two operators, two arguments. The first is the IP, and then second is the subnet mask. What we are doing here is, like, since we have multiple subnets, we are using the MV apply and then look up, and then it will basically look through all these subnets and then match on each of the destination IP in this data set. Pretty powerful stuff. The last thing is Windows XML. So if you have seen, Windows XML has a lot of data packed into event data field, all of that into a XML blob. If you try to parse through parse XML, you have to do like a lot of stuff. This is another example where you are doing a dynamic query. So you don't have to basically look through each of the fields manually. So in this case, again, I have dynamically extracted name and value pair, and then using the pivot operator. So pivot is something similar to pivot table in Excel. So you can create columns into a table. External data. So many times the data is not present into your same environment. So you may have to connect to some of the web data providers. So in this case, Microsoft has published some COVID-19 file hashes onto the GitHub. This link gets updated every week. So you can just use this query to access this link, which is in the text CSV files with this schema, and then extract as a table. Once you load it as a temp table, you can join this table on your data sources, which contains the file hash via joining or multiple other operators. Another example is the Azure Appearances public cloud. So Microsoft also publish a variety of subnets that are related to Azure IP ranges. So if you wanted to match those subnets into your data sets, this is the link that you can use. So in this case, this link is not static. It gets changed every week or so. So I've written a blog basically to explain how you can use Azure functions to automate that stuff, and then create a static link as a blob storage, and then replace that here. Okay, let's look at the time series analysis, which is going to be our first demo of the end-to-end use cases. So time series is one of the statistical or machine learning capability within KQL. So KQL has built-in functions and operators that will make time series analysis very easy. So you don't have to know complex mathematical stuffs. You just have to know on which fields you have to run, and then how do we call the function. So if you don't know, time series is basically two-dimensional data sets. The first axis, the x-axis, you will have time, and then y-axis, you will have typically any numerical count. So in this case, we are looking for a log-on count of last 90 days. Right? So this is we have plotted the line chart, so you can see some patterns here. But if you want to run the time series analysis on this, you'll have to basically use these operators. Make series is the one which will convert your data into a time series format. And then series decompose it will decompose your time series into variety of components such as seasonal, trend, residual. So through which you can understand if there are seasonal patterns such as weekends or weekdays or after hours, like that. And then last thing is the actual anomalous function. So just pass whatever the time series data we have prepared into these functions, and it will apply the Tukey's algorithm to find anomalies, which will be the spikes and dips. Again, the blog is there to read more about it. So what are the use cases where you can use the this particular time series analysis, right? So these are a variety of data sources: cloud, network, host, and these are the specific event types. I have also mapped to the MITRE tactics for each of the detections, so that will be helpful. So you can see like pretty time, many time if you just wanted to access the secret access events from keyword, so that can be converted into time series, and then you can run on the time series analysis operation. Let's look at the how do we compile the actual time series use case here. So if you recall our structure of basic KQL query, we'll declare the variable, we'll convert the time series data, run the anomaly detection, and then investigate the anomalies. So first things first, we declare the variables. The dynamic variable here is the exe list, where we are passing multiple executables. So these are the executables, PowerShell system executables that are present in your Windows. The next thing is we are looking for all the process execution events for this exe list, which we have declared above, and then use make series operator to convert into time series data. Right. We are also doing a step called time frame, which is 1 hour. So it will basically aggregate hourly count for each of these processes for 14 days. Right. The next thing is we have converted. We have prepared this time series. Now run time series data, series decompose anomalous functions on the numerical count, that is the Y column, total, which is the log, which is the process execution count in this case. And then these are the arguments that are passed to the series decompose. So this function will output these three fields. For example, anomaly, score, and baseline. So anomalies will have a binary output 0, 1, and -1. So in this case, we are only interested into the positive anomalies. So we'll look into only the spikes and not the dips. And then lastly, once you find out the time series alerts, join with your original base data set to find out or to gather what additional processes executed during that time window. So typically the time series alerts will output a time window or like hourly time window in which it has observed the spike or dips. You will have to go back and then check what has happened in that particular time window hour to see or to find out the malicious activity. Awesome. So another use case that we are going to look into is the network beaconing. This is based on the previous work that was done by Threat Hunting Project, which is the GitHub that you can check out. And then another open source tool called Flare, written by Austin Taylor. So they have implemented these approaches. I have basically ported that same logic into a KQL. So this is how the workflow looks like. You will have raw sampled network connection logs. You will basically filter only the internal to external traffic via matches regex that we saw earlier. We'll serialize the data, sort by and serialize it. We'll calculate the time delta by using previous, next, and date time difference. Then we'll convert that into a data reshaping, count, sum, bin, make list, and argument max, and then filter via some threshold parameters, and then finally convert into an alerts. Okay, let's look at the query here again. So we have declared certain variables here. The next thing that we are looking for is we are only looking for some IP list which has decount source IP as less than 5. So I'm only looking for the public IP addresses for which less than 5 hosts inside your environment has tried to connect. So this will reduce your false positive to commonly reached out to public IP addresses such as Windows Update and some agent-based tools in your environment. Right. Once you found out those destination IP list, let's run through the common security logs and then output these fields here. The next thing is we'll serialize these, sort by source IP, time generated, destination IP, destination port, and then use serialize operator. Next thing is we'll calculate the time delta. So here you can see like there are functions called previous and next through which you can access the previous event and next events. In order to call these functions, you have to call a serialize operator. And then lastly, you will apply the threat whitelisting criteria and the threshold criteria to filter out the values. Next, I'm doing some aggregation via make list and also using the arg_max to basically find out what is the frequently appearing time delta so that we can calculate the percentage at the end. And then anytime you observe more than 80% of same source IP destination IP pair, it will trigger an alert. Now, I know like walking through the query gets little bit complicated unless we see the output. So this is an example of output that you can see. So this is the original firewall logs that you can see here. This is the format. So these are unsampled. So there is no aggregation present. So once you apply the query, it will convert into this sort of row, which is like source IP, destination IP, and then most frequent time delta, and then percentage of beaconing pattern. All right, let's look at the programmatic interfaces for KQL. Now, there are a variety of Python libraries from Microsoft. One is the KQL Magic and another one is the Mystic Py. So big shout out to my colleagues, Ian, Helen, Pete, Brian. They have written a variety of cool features in Mystic Py that you can check out. So one of the features that we are going to talk here is the query provider. Now, the idea here is basically you will have multiple data sources such as these in the list. And then once you connect to these data sources, you will typically run the queries for that. So here you can see that these are the functions that will call into it. Very recently, Ian also wrote capabilities so that you can split giant queries into chunks. So you can check it. So let me just switch to all right. So let's restart this kernel. So this is the notebook that you can check out. This is available in the GitHub. So we'll start with the Mystic Py. This is already installed here. So I'm basically loading some modules here. Query reader, query provider. So once I executed this, import is complete without any error. Next thing, what we're doing is we are checking what are the data environments present. So these are the variety of data providers that are supported. One of them is Azure Sentinel. So the next thing is we are passing this some parameters respect to your environment. We also have an option so that you can read from config file in other notebooks. So I basically authenticated against my workspace. So once you authenticated to this workspace, this will show as a pop-up schema for these things, right? So this is completed. The next thing is like now we have connected to a log analytics provider, which is Sentinel. So you can run the list queries. So these are the built-in queries that are provided. We have documented all of these queries into read the docs that you can check out. So as you can see, this is the data provider dot. This is the query for that particular data provider. Right. So there are a bunch of queries that are defined as YAML format. If you want to take help of the specific query, you can run this command with the argument as question mark. So it will basically output what is the query, what are the parameters that you can support. The next section is how do we run the predefined query. So this list alert is already present as a built-in query. So you can just pass timestamp and then it will basically output the list of security alert. Right. The next thing is there's a widget interface as well. So you can provide the input date time. It will basically pick up time window from these widgets now. Right. Okay, sorry for the rapid scrolling here. Just a second. Yeah. So this will output for those time window. We have 385 alerts. Now, if you want to run a custom query, so this is how you can define the query and then run via exec query function. Right. So we're running a little out of time. So I'll speed through this. So another thing is like you can specify your own YAML file. So I've specified a data directory in which it has found the YAML format. So this is the example YAML format, how it looks like. I'll just speed through it since I do not have a lot of time. So you can import this YAML file via import query file function. And then once it imported, you can again run the list query function. So in this case, as you can see, this is the newly imported example query. You can go back and validate this query was not present earlier. The same thing, and then pass parameters. In this case, we have passed the host name parameter, DB server. And then if you just wanted to output the query that's going to run, here is the syslog type. So this is very powerful stuff if you want to automate your threat hunting operations and then do some threat hunting at scale via multiple queries via Jupyter notebooks. All right. So where do we go from here? So now, even if you do not have any infrastructures to try out KQL today, these are the demo instances that are available. You can go and try out. You will only need some Microsoft account like Outlook or Hotmail or those things to log into these instances and then execute those queries. The another thing is like if you wanted to set up your own lab, Cyber Wardog or Roboto recently joined our team. He has came up with this project Sentinel to go. It's basically a collection of ARM templates that has a one-click button to deploy. So there are a variety of scenarios where you can spin up like Windows host or Windows host plus DC, Windows host or plus Palo Alto or simply a Linux host. There are also like this talk was probably a lot of information packed into this 45-minute talk. If you wanted to take it slow and then take a hands-on approach, look for these free trainings at plural sites. We also have like ninja trainings for Azure Sentinel as well as for the Defender. So these are the trainings that you can check out. There are specific sections related to the click. Lastly, these are some of the GitHub repository. Apart from this, there are also like community guides. There is a KQL tag Stack Overflow functions that you can check out. Builtin Labs Sentinel attack is another project where you can find a lot of Sysmon-based queries. KQL internal docs was written by Debug Privileges. It's more than 200 pages that you can check out. Kusto Query is the recently blog written by Johnny. He comes up with his own experiences of using KQL from a security consulting background. So there are, in addition to this, there are like more queries that are shared by community on GitHub and Twitter on blogs that you can check out. So, okay, so let's wrap up this just at the end of the 45-minute. So as you may have seen, the KQL provides a powerful data analysis framework to analysts. If you master KQL skills, that will really supercharge your Defender. You'll be able to find stuff faster and with efficient manner. Lastly, before writing something on your own, see like if somebody has already written that or published somewhere. So there are some community built resources and queries that you can leverage. Also, feel free to share your queries with the community and also consider contributing to Azure Sentinel GitHub. With that, I'll wrap up. I'll be available in Discord to answer any questions, or feel free to reach out to me via Twitter, LinkedIn, or any other social media channel.